Okay, so one of the most powerful and interesting subjects in all of mathematics is calculus. And that's what this is right here. This is an example of what calculus looks like. And most people, unfortunately, do not take calculus, okay? And probably for two reasons. One, there is no need to take calculus because typically the only people that need to take calculus are those that might be going into engineering or science. But there's another reason why a lot of people never took calculus, and that's because it just looks so complex. It looks so intimidating and advanced. And that's what I want to kind of focus on in this video. I want to give you a basic understanding of calculus. And one of the cool things you can do with calculus, so you can just have an appreciation of how amazing calculus is. Now, the only requirement in terms of mathematics, prerequisites to watch this video is simply just an interest in calculus. You don't need to know advanced algebra to understand what I'm going to be talking about. So stick with me for a couple minutes, and by the time you finish this video, I promise you that you'll be able to do this basic calculus problem all on your own, irrespective of your current math background. All right, so that is my objective. But before we get started, let me quickly introduce myself. My name is John, and I've been teaching middle and high school math for decades. And it really is my true passion to try to make learning mathematics as easy as possible. So if you need assistance in math, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if you find this video interesting or if you just like it, make sure to hit that like button and that subscribe button, as that definitely helps me out. Okay, so again, the whole goal here is just to give you a sense of why calculus is awesome. And I think I'm going to be able to get you to do this basic calculus problem at the end of this little video. I'm going to kind of keep this pretty short, but I do need to cover a few basic things here. So again, we want to understand basic calculus, and let's get going. All right, so one of the most powerful things that calculus does for us, it basically finds the area of things. Now let me kind of set this up. So let's suppose I have these shapes right here. I have a rectangle, a circle, and a triangle. And I said, hey, let's find the area of these shapes. No problem. What we can do is get the formula for these respective shapes, and hopefully you remember this from your basic geometry. So the area of a rectangle, for example, is length times the width. The area of a circle is pi r squared. And the area of a triangle is 1/2 base times the height, right? No problem. You're like, yes, indeed, I can find the area of any shape you give me as long as you give me the formula. All right, but what about a shape like this? Okay, what if I said find the area of this thing right here? Now notice this shape, I just didn't give you this shape like this. Now I don't even know the name of this shape. We could just call it, a thingamajiggy. Like, hey, find the area of a thingamajiggy, and you would say, no problem, give me the formula. Okay, well, guess what? I don't have a formula. There is no formula that exists to find the area of this kind of shape. So what do? Well, this is where calculus comes to the rescue. And what we're going to do here is take this shape that we want to find the area of, and we're going to look at that shape in terms of it on an XY plane. Okay, so this is where some basic algebra knowledge is very helpful. So in mathematics and algebra, we can graph all different sorts of things on a basic XY coordinate plane. All right, just think of this as like graph paper that you might have. And so here we can kind of draw any curve or any kind of line that we want, and we could put it again in context of this X and Y axis. Now, in math, what we can do in algebra is we can find equations that describe this curve, okay? And what we're going to do here is pretty much look at this shape that we're interested in, but we're going to kind of define it by using the y-axis or the x-axis or both, okay? Now, again, I'm going to keep this very, very basic because I don't want to overwhelm you with too many, scenarios here. So let's just focus in on how we would find the area of this particular shape. Okay, so what we want to do is find first the equation that describes this curve right here. Now in algebra, You can, again, I'm saying algebra, not calculus. In algebra, curves that are on the xy plane, you can find associated equations that define that curve. Okay, and that's not that all that difficult as well. But just know that curves and lines and whatnot can be described by equations. This particular curve right here, this is called a parabola, and this right here could be an example of an equation that defines this curve. Okay, no problem. So this curve again is defined by this equation, y is equal to x squared plus 2. And what we're going to do is we're going to draw lines down underneath that curve, and we're going to use the y-axis and the x-axis, and we're just kind of focus in just like this. Okay, so again, this is the shape that we want to find the area of. Now, on the x-axis here, and the y-axis as well, these are basically there's values on this number line. Okay, so in other words, this would be 1, 2, 3, 4, 5, 6, 7. This is -1, -2, etc., and +1, +2, +3, +4, -1, etc. So again, if you understand basic algebra, you would clearly understand this. But for those of you that only know basic mathematics, this is how this XY coordinate plane works. So right in here is our curve, okay? Now we're going to use calculus to find the area underneath this curve, which is, again, this shape that we're looking for, okay? So how do we do that? Well, this is the notation for it. We're not going to do this problem. We're going to do a problem that's a little bit easier than this. Matter of fact, I think you're going to be able to do this problem after I teach you a couple basic things here. But in calculus, we have this little crazy symbol like this, okay? This is called the elongated S. Matter of fact, I'll draw it right here. It looks like an S and it's elongated, and this is what we call an integral, okay? Very, very famous calculus symbol. Matter of fact, when people think of calculus, they think of this symbol here. And what we're going to do is say we want to find, this is basically stating, hey, we want to find the area of something. And we want to find the area underneath this curve, x squared plus 2. And of course, this is the curve that defines this thing right here. Don't worry about this little notation, dx. That's just something that we need in calculus, but it's not that important to understand these concepts. And so what we're going to do is say, hey, we want to find the area underneath this curve right here, okay? And we want to put in on the x-axis where the curve starts and where it ends. So we want to start from 0. Right here is 0 on the curve, right there. And we want to go all the way out to 4. Okay, 0 to 4. Underneath that curve defines this shape right there. Okay, so hopefully you can see that. So we're going to start at 0, go all the way out to 4, and that would be this shape right here. So in calculus, we're going to say, the notation again is going to be, all right, from 0 to 4, we want to find the area underneath the curve, x squared plus 2. Okay, this is very, very basic. But if you understand this notation, well, then you are understanding basic calculus. Now, how we calculate the area, I'm going to show you that in just 1 second. Okay, all right, so let's take a look at an example to see how cool calculus is. So what we're going to do is find the area of a triangle. Okay, we're going to find the area of a triangle using the regular formula for the area of a triangle. Of course, we have this right here. Area equals 1/2 base times height. And then we're going to do the same problem using calculus just so you can see, yes, indeed, this stuff really works. All right, so let's go to our XY plane here. In a 45-degree line in algebra, we can express this line as the line y equals x. Okay, y equals x. This is this line. So what we want to do, okay, in a second here is we're going to use calculus to find the area underneath this line. But let's just take a look at a triangle here, and we're going to go from 0 on the x out to 6. So this is going to be 6 right here. And the height of this triangle is also going to be 6, okay? So this right here, this x value is 6. So if y is equal to 6, this y value right here is also 6. So what we have is a triangle where the base and the height is 6. All right, so effectively if I said, hey, find the area of this triangle right here where it's 6 right here, 6 right here, you would say, no problem. Let me get that formula out. Area is equal to 1/2 base times height. So area is equal to 1/2 6 times 6, which of course is 36. 1/2 of 36 is 18. Okay, so the area of this triangle right here is 18. No problem. Now, let's do the same problem, okay, using calculus, right? So if we do this right, the area should be 18. So let's go ahead and apply these concepts I just talked about. All right, so here is the same problem. And again, here is our line, and it's being defined by the equation y equals x, and we want to find the area underneath this line from 0 out to 6. Okay, so this side would be 6, and of course this side would also be 6, but we're not looking at the problem in those terms anymore. Okay, we're looking at, all right, we want to find this triangle that's underneath this line that starts from 0 on the x-axis and goes all the way out to 6. So this is the calculus notation. Let's find the area. Okay, here I'll do this a little bit bigger here. Area from 0 to 6 underneath the curve x, right? So you don't put the y part, you just put the x part, x, and then there's a little dx there. That's not as really, it's important, but not so important to understand the basic concepts here, right? So if we figure out this, we actually do the calculations here. This is going to give us the area of that triangle. Now we just actually did this problem, right? We know that the area is 18, so let's go ahead and see how this works with calculus in terms of actually calculating the area. Okay, so take special note because I'm going to give you a problem for you to do all on your own, and this is very, very simple. All right, so here is the setup, right? So this is, let's find the integral, okay, or the area. That's how we would call that in calculus. This is the integral. We want to find the integral from 0 to 6. These are called the limits. It's not so important for you to understand that right now. So 0 to 6, x dx. Okay, don't worry about that, but this is proper calculus notation. Okay, this is how you do this. Super simple. Now, x by itself, x is x to the first power. Okay, we don't write things like x to the first power. We just write x. Okay, so if there's x to the second power, we leave that little 2. But x to the first power, we'll just represent that as x. We don't really put a 1 up there, but there is a 1. Okay, and that's important for you to understand because this is how we are going to what we call evaluate this integral. Okay, and again, I'm using very informal terminology. So if some of you out there, have taken calculus, you would say, hey, you're not saying this, you're not saying that. Well, we're keeping this super basic. Okay, so here is x to the first. Okay, now let's pay attention here because this is how we are going to find this integral. Okay, so x to the first, what we're going to do, the rule is the following. We're going to add 1, specifically a 1 to the power. So if I have x to the first, I am going to add 1 to it. So now let's add up the power now. That's 1 plus 1 is what? 2, right? So let me just review that, right? We have x to the first. We're going to add 1 to that power. So that's going to be 1 plus 1. And that answer is 2. So whatever the answer is, we're going to divide by it. So we're going to end up with x squared over 2. Okay, I'll say that one more time because if you understand this, then you're going to be able to do this next problem. Okay, so here we have this x all by itself, and it's x to the first. Okay, so we're going to evaluate this integral. We're going to add 1, okay, to the power. So that's 1 plus 1, which of course is 2. So now we have x squared. And this power here, the result of adding 1 to it, we're going to divide by that number. Okay, so when we do this, this integral, okay, that's how we call this in calculus, this thing is going to be equal to x squared over 2. All right, okay, so we're almost there. And what do we do next? Well, we're going to evaluate this thing right here using the limits of the integral. Okay, so here it goes, the next step. Okay, so here it's the integral, okay, of x, 0 to 6 dx. We just found out that it's equal to x squared over 2. Okay, remember, we just added 1, took that answer and divided it by it. Now, we have to use these numbers, 0 and 6. So what you're going to do, you're going to take the top number, the top limit, right? And in our little thing right here, that's 0 to 6. This 6, you're going to plug it in for x right here. Okay, but let me kind of make this a little bit more clear, kind of skipping a little bit too much here. So here we have x squared over 2. So we're going to take this thing and subtract it from itself. Okay, we're going to take what we got and we're going to subtract it from itself. So that's this step right here. And this is the way it's going to work for all calculus problems. So this answer, we're going to subtract it from itself. But what we're going to do is we're going to take these values right here, 6, the top value in this integral, we're going to plug it in right here, and the bottom value, we're going to plug it in right here. Okay, so the top value gets plugged in to the left, and the bottom value gets plugged in to the right. So now all we got to do is this number crunching, and we're talking about basic algebra, and then we'll get the right answer. Okay, so let's go into that now. So when we plug in 6 for the top value, this is going to be 6 squared, right? 6 squared over 2 minus, remember our bottom value here is 0. Okay, so this is 0. We're going to plug in right here. So that's 0 squared over 2. All right, so you can see this math right here. So 6 squared is what? 36. This would be 36 over 2. That's that right there. 0 squared is 0 divided by 2 is just 0. Okay, so now we have 36 over 2 minus 0. And what is 36 divided by 2? It is 18. All right, so 18 indeed is the area of this triangle. Okay, but we did this using calculus. Now, some of you might be saying, well, that's a lot of work. I would just use the formula for this triangle. Well, yes, indeed. That's the way to go. But if you understand these steps I just took, you will be able to do this next problem that's a lot more interesting than this triangle problem. We're going to get to that in just one second because here, matter of fact, is the problem that we're going to be doing. Okay, so let's see if you can do this. I think you can, okay? All right, so the objective here is to find the area of this little strip right there, okay? So what you want to do first is set up your integral. Okay, so you want to set up your integral. This y equals x squared. This is the equation for this curve right here. And here is your limits, right? You're going to start from 2 and go to 3. Okay, so let's see if you can set up the integral. Now, once you have the integral set up, right, then you're going to walk through these steps. You're going to add 1. Remember, you're going to add 1 to the power. Whatever the result is, you're going to divide by 2. And then once you have that, you're going to subtract from one another and plug in these respective values. So if you want to kind of rewind the video a little bit to kind of refresh your memory on that, you'll see that I bet you a lot of you are going to be able to actually do this calculus problem without me showing you the answer just yet. Okay, let's see if you can actually do this. Okay, so of course I'm going to show you the solution, but I want to give you an opportunity to set this thing up and actually go through the calculations because it's basically the exact same thing as what I just showed you with the triangle. Okay, so let's go ahead and look at the setup here. And what we have is we have this integral, okay? We want to go from 2 to 3. So 2 is your left limit, okay, your bottom to your top limit, 2 to 3. And this is this blue part right here underneath this curve. And we're doing this underneath the curve x squared dx. All right, now if you got this right, that's very, very good. All right, so this is the calculus notation to define the area of this little crazy shape right here. Okay, just like that, defined in blue. All right, so now remember, we're going to have to do what? You're going to have to do all that stuff with the power. You're going to have to evaluate, find the integral of this. Okay, so I told you the steps. I don't want to tell you them again because I want to see if you can remember. And then once you're done with that, remember you're going to subtract it from one another. You're going to take this value, you're going to plug it in right here, take that value, plug it in right there, do all that math. And if you do this right, you'll find the area of this shape. Okay, in other words, you are doing calculus. Okay, so let's go ahead and take a look at this right now. Okay, so let's find the integral of this. And the first thing we need to do is add 1 to the power. So x squared plus 1, 2 plus 1, of course, is 3. So we're going to end up with x to the third power. And remember, this is our answer, 3. So we're going to divide by it. All right, so this is what the result is of finding this integral. Now, what do we do with this? Well, remember, we're going to take this and subtract it from itself, and we're going to take that top value, 3, we're going to plug it in right here, and take that bottom value, plug it in for x right here, and then do all this number crunching, and you will magically have calculated the area of this little shape using calculus. All right, so let's go ahead and set this up right now just to make this clear. Okay, so here is the integral. Again, you're going to be plugging in the top value for the first expression, and then this bottom value too for this one. All right, so I'm pretty much, given this all set up for you, all ready to go. All you have to do is actually plug in the information. Feel free to use a calculator, by the way, and let's see if you can get the right answer. I suspect most of you will have the right answer. Okay, so let's go to continue on, and what I want to do is invite you to subscribe to my YouTube channel before I show you the final solution. If you enjoy this content, if you like learning math, if you're just interested in math, or if you need help in math, by you subscribing, it really does help me find more people like yourself, right? And it really does help me personally, but really it helps me help others. Okay, so thank you so much for being with me, all the way into this, this far into the video. I really do try to come up with creative and, interesting, valuable things that I can try to teach, from a mathematics angle. So by you subscribing, again, it really does help me out. Make sure you hit that notification button as well. And if you're new to my channel, just want to let you know that I have 2,000 plus videos from basic math to advanced math. So, and everything in between. So if you like geometry or trigonometry or algebra, more advanced algebra, you'll pretty much find topics and all that stuff on my channel. Okay, so let's go ahead and finish this problem up. We're almost there. All right, so here are our limits. Again, we're going to plug in the top. Remember, we had that integral from 2 to 3. The 3 is going to go in right here, and then the 2 is going to go in over here for x, right? We're replacing x with these values. So this is going to be 3 cubed over 3 minus 2 cubed over 3. So 3 cubed is 3 times 3 times 3, which of course is 27 divided by 3. Minus 2 cubed is 2 times 2 times 2, which is 8 over 3. And when we do this lovely fraction here, 27 over 3 minus 8 over 3, again, we have fractions, so we just simply need to subtract the numerators here, right? We've got the same common denominator. We got 19 over 3, and then, of course, we could just divide that in our calculator, and that is approximately 6.3. Okay, now if you got 6.3, that is fantastic because you just used calculus to find the area of this shape right here. There is no formula that exists to do this right here. There's a 2 we're missing right there. So you used calculus. Okay, now if you are like, wow, I actually did this, well, that is amazing. Okay, listen, here's the deal, right? If you are like interested, like, this is kind of interesting, what you need to do is just build up and get ready. If you want to take calculus, like in terms of full course, it is a challenging course. There is a lot to learn, but the concepts I don't think are overly difficult, at least to get an appreciation of. And one of the biggest problems that calculus solves is finding area and volume and surface area of all different sorts of shapes where we don't have formulas. Okay, so anyways, I hope you enjoyed this video. I hope it made sense to those, but most importantly, I hope a lot of you are like, wow, more enthusiastic about maybe wanting to actually take calculus. Now, if you do want to take calculus, you're going to have to complete a course called Pre-Calculus. Now, that's a pretty advanced course. Matter of fact, I'm going to leave a link to my pre-calculus course, in the description. So if you want to check that out, that is a pretty advanced course, but that's the course you have to take, get through completely before you are ready to take an actual full college level calculus course. And if you're not ready for pre-calculus, well, there's other courses there you can take, like pre-algebra, algebra 1, geometry, algebra 2, etc. But here's the bottom line, okay? Wherever you're at in math, even if you only know basic math, you can take the steps if you want, okay, if you want to put the work into it, to actually get to the level of calculus. Okay, so with all that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time, and have a great day.